Hi everyone. So this is the part where we get to do our practical example, and in this practical example, we're going to do an image classification problem, of which we're going to do this tomato disease classification using deep learning. And in this project, we'll use a dataset from Kaggle, downloaded from the Kaggle, and I'll include the link of this Kaggle dataset. And it has, I've actually taken out some of the images. So I found a dataset that has healthy leaves, yellow curl leaves, affected by this virus, yellow leaf curl virus, and a bacteria spot. So this is just to show you how deep learning can be used when you want to have models that can identify which type of diseases has affected your crops. So the first thing also, the first part now, this classification class, we'll start how you can read images, how you will use TensorFlow and Keras, how we're going to use that TF.data input pipeline, and some data argumentation. So that's the first part of the class, what we'll cover. So to begin with, I want you to show you, first thing we need to know, this is my data set. Let me show you the data set now. So here's my data set. My data set has, it's in a folder called lesson 5, and it has a data set which is this images, 3 classes corresponding to the 3 folders, where we have healthy, we have the ones that are affected with bacteria, the ones that are affected with the virus. So these are my data set, and these will be the corresponding classes. And so let's go back to our where we are. So yeah, so before we do that, we need to understand that actually. And so, and one thing you should note that this model is this classification model. We can just leave it for now. We can open name it as tomato leaf. Tomato leaf classification. So and this Jupyter Notebook is actually within the same image directory. I mean, not this. It's within the same folder where we have the dataset as well as the the notebook. So the first thing we're going to do is, like we normally do, we have to import the necessary libraries and import all the dependencies. And in our case, we're going to use the first thing we have to import TensorFlow. This is the library we import TensorFlow. Then we're going to, from TensorFlow, because we're also using Keras, so we're going to use from TensorFlow. We're going to import a model and sorry. Import models and layers also. And we're going to use matplotlib to visualize data. So we'll import the matplotlib library. Import matplotlib. And we're going to use, at some point, you're going to use NumPy. So I'll just import it also. Import NumPy as NP. So these are the libraries that we're going to use. And and after that, now we're going to read our images. And like I said, we're going to use the TensorFlow input pipeline, the tf.data. So we're going to define our image data set. So we're going to say image data set. Let me call it image data set is equal to, now we're going to use this library, the TensorFlow input pipeline, the tf.library. So like I want you to show the documentation. Let's see. So this is we're going to use in tf.keras preprocessing image data set from directory. So if you search this image data set from directory, you're going to want to get the documentation of this okay, so we can like, so if you look at the documentation of this so this image data set, it says that it generates the input pipeline, the tf.data input data set from the image files directory. So and then these are the arguments that it accepts. The first thing that you need to specify the directory, you need to specify the class names, the batch size, the image size. So we're going to use that in our, so the first thing is that it's going to specify where our data set is. So our data set is, it's labeled as data set. If you look at this from lesson 5 here, so our images are in this data set. Okay, so we're going to the first thing is that it's the data set, and then after the data set, we're going to shuffle. We want it to shuffle, so we're going to specify shuffle equals to true. I want it to shuffle, so shuffle is going to be true, and then so shuffle is going to be true. Then the next thing is that we're going to need our batch size. We're going to like take it from this documentation. You can see that you need to specify the image size, you need to specify the batch size, the directory, and so on. So let's get our batch size and our image size and so on. So what is our image size? So we need to get our image size. Then we need to get our image size. We need to get our batch size. So let's get our image size is equal to, so you can get your image size, or you can just from the data set. Let me show you. Like what is our image size? You can just write it as 256 by 256. Let me share this. For instance, let's get these are images. So from these images, you can get you can see these images. These are like 1,000 items. So if you click on each image, you can see it how it is from each directory, and you can see that the difference between the two. So these are the images that are affected with the bacteria case. So if you want to get the size, so you can see that these images have 256 by 256 as the image size. So we're going to need to specify that in our model. So we can just instead of writing 256, we can just use image size. I can just, and then I'll define it. So image size. So it's like saying 256 by 256. It's only that I'm going to add, I have to add another saying that what is our image size. So this image size, let's say image size equal to 250 is 256. And then we also have to use what is our batch size. So our batch size, You know, most of the time we use 32 as our batch size, more like a so say our batch size is 32. So I'm also going to specify here the batch size according to what this what it needs. So our batch size is going to be 32. In our case, we're just going to just say batch size is equal to this. And so this will be our batch size. So I've specified the data set that is going to be shuffled, the image size, the batch size, as well as I think for now we can use that one. And we can run this. We need to run this to get our batch size. We can also run this. So it has to. Oh, sorry. So it gets me. Yeah. I didn't put a comma here, so that's the error. So yeah. So it tells us it found 3,000 files belonging to 3 classes. So now we need to get. We can get the class names. So we can say class names is equal to. We need to know what are those classes. So let me say that class names. I want to get class names is equal to, we're going to use the same data set. So we're going to get, we want to get the class names from this data set. And these class names correspond to so these class names correspond to the folders that are there in this so if I print them, I'm gonna see this. So it has 3 classes, which are tomato bacteria, tomato leaf with the virus, and so these are the classes that they correspond. And if you can check even from this documentation, is that if your data set is in the you have the main directory, so the first class will be the first folder, then the second, and it has its images, and then the second class, and so on. So that's how these are the classes. Then we can also get the length of this image data set. We want to get the length of our data set. So if I get the length of the length of this image data set. So this is the length of the data set. So I want to get the length of the data set, and it tells me that it's 94. And this is 94 because the images are now grouped into batches. Now that's the good thing about using this. So they're grouped into batches of 32. So meaning that if you want to get, you can get, let's get 94 times 32. You get a number that is roughly close to 3,000, meaning that you have 3,000 images, 94 batches, each has 32 images. So that's the essence of that. And then now we want to explore the data set. Let's say we want to know what is in the data set. Now we can use the for loop. To say for loop, we want to use to get the image. Let's say image batch and the labels in that data set in our data set, which is the images data set, and I'm just going to take only one batch. So let's say take only one. Let's see how this take method becomes really useful. Just one. So I'm going to let me just for it to become easy. Let's say just explore it. Here we're just exploring the data set. Nothing much we're doing here. So if I want to print, maybe I want to print the shape of this data set as well as the labels. So let's say we're going to print the shape image. We're going to use image batch. We're going to print that, and we're going to say the shape, and also we want to print the labels. So print labels, label. And because these are tensors, so I just want it to be shown as a numpy. So I'm going to just use it as a numpy. So let's see that. So it tells us, oh, sorry. So this is the numpy, sorry. So this tells us that this is an image with have 32, and there are 250, and this is 256 times 250. That's the size of those images, and 3 images. This is the number of channels. So the number of channels. So it's 3, and this 1 1 1 2 3 0 0, meaning that this is 1 corresponding to 1, 2, and 6. So these are the classes. Okay, so what if you want to print our first image? Let's say you can print, let's say, let's print our first image in that batch. So we can print first image in the batch. Okay, in that batch, in the first batch, actually the first batch that is being displayed. So I'm just going to use the same thing. So I can just use this method, and then I can use this. I'm going to go to print instead of I'm going to print like this because it's a tensor. I'm going to even convert it to, I just want to print the first image. So 0 numpy. This is a tensor. So if I just print this, you can, let me print that, and you see it's a tensor. You see it's printing as a tensor, right? Yeah, tensor. So you have to convert it into a numpy. Print it as a numpy. So it will have values ranging, to 255, yeah. So you can also, now we have just printed the first images. What if you want to print, visualize, we can visualize it actually. This is just showing numbers. So what if we want to, visualize it? So yeah, for you to understand, I'm just going to like repeat this. So let's say like visualizing it using the matplotlib now, so we're going to visualize it. So in the same thing, instead of now of printing, we are going to like we're going to use the plt.arm show. Okay, so we're going to plt imp show, and what we're going to show here, we are going to show the first, which is a numpy, but this is it's just like a thought, right? So we're going to what we're going to do is we can convert this into as a unified integer. And yeah, we can run that. So you can see it's plotting the first image. This is how it's plotted. You can also we can say let's give it a title. So I'll use title to get what's this image actually. Is it a healthy? Is it the one with bacteria, or is this the one with the so we're going to use the label batch. Now I want to show you something here. So we're going to use this label batch of the first, actually the first image. So let me print this and you can see what it does. So That's low. We have to like so we're going to pass the class this as a class from our class names, so it will get the class names. Like the class names is the one that we have these, so we're going to pass it here. So class name, is it class name or class names? Yeah, so I'm just going to copy it so that I don't get errors again. So yeah, so we're going to copy that class names, and then we're going to pass it in our label. So yeah, that shouldn't give us an error. So you see, it tells us this is a tomato healthy. The class is healthy. If I run this again, it's because it's being shuffled. It will display another image. So it's displaying another tomato yellow leaf virus. Oh, and if you don't want to have these axes, you can put them off. So you can also like put the axis off. The axis, you can say off, so that you just display the image and not all these other numbers here. So yeah. So we can see this is another one. So whenever I run it, it is going to display another image because it's being shuffled. And then yeah, this is just showing one image. So what if we want to like show like 10 or the first 10 or 12, depending on what. So let's like, let me show you how to do that. So I can just copy this because it's just more than an extension. So for the first image batch, so one thing is that, so we're going to get the image batch and the label batch in the same data set, and we're going to take the first batch, and we're going to get a range, let's say for I in let's say just like 10 or 12. Let's say we're going to print like the first 12 images, let's say. So in the batch with 32 images, we're just going to print 12 images. And so, and then we have to include a subplot. So I want this to have a subplot that tells us the number of rows and columns that are there. So I'm going to use the plt dot subplot, and we have to have like 3, because I'm printing 12. I want to have 3 rows, 4 columns, and they should increment I plus 1. So I plus 1. And this should be here with this. So you just need it to be nice and neat. And yeah. So yeah, it's going to do that, and this has to be because it's iterating. So this is I, and it's also I. So yeah, let's print that for I in range 12. Yeah, I hope we're good. So yeah, you see how it has printed these 12 images, but it's kind of messed up. So we can have a figure size. So let's say plt figure. We had to increase this because the space is just too small. So we can do that. So we're going to increase the area. So let's specify our figure size. Let's say, the words are kind of long, so we can have our figure size maybe, let's say 15. by 15. So this will be our figure size, and yeah, we can run this. Let's see. So you can see how these have now, have that space, or even this is kind of still small. So we can add maybe 18, maybe. So you can see how you visualize your data, so that you can get to know what is in your data set and how these images are looking like. So these are images. We have like 3 rows and 4 columns displaying these images. So that's how you can read. That's another way you can read multiple images using this TensorFlow. Using Matplotlib. So that's how you do it. So then what else we're going to do is we're going to split our data set. First, we can get the length of our data set. We can, let's print length of our data set. So length of our image data set. What is the length of our data set? So this is the name of our data set. So image data set is image data set. So we need to get the length now. So let's get the length of our data set. So let's do that. We can run that. So yeah, we got it as 94. So it has 94 batches, all that has 32 images. And now we want to split these batches into train, test, and validation data sets. We can use the test method like we did in the previous classes, or we can just define a function that that can do all that, the train, the test, and validation data set all defined. So let me just copy it here. I had defined it already. So this is our data set, and we're going to we're going to have these. This is the data set. So we're going to have splitting it into train, test, and validation. So like I said, and the data set is going to be the length of our data set, and we're going to shuffle it, and you can start seed is any number. You can start from any number, 12 or whatever. You can use any number, and then we're going to use so the train size is equal to like we did in the previous class. So we're going to data set size times 0.8. So for case 0, we have defined our train, the split is 0.8. And we need to get an integer value. That's why we have used this integer. The validation split is equal to also times the data size, so 0.1 times that. So the training data set, we're going to take the first 80% of the data set, and then we're going to get the validation data set, we're going to skip those 80% of that data set. And then the test data set, we're going to skip now the ones in the validation side. So that's how you do. This is a function that returns the training data set, the validation data set, as well as the test data set. So this is easier to use. Yeah, so this is just the function that is going to split our data set into the normal 0.8, 80%, 10%, and 10%. Okay, now so let's see it. Let's get it from our data set. So we just want, because it's going to return this, we can just put this, and then we call that function. Our function is get data set. So we're going to call this, and what it's going to take is going to take our images data set as an argument. So let's do that. So let's run this. Okay, so we can also print the length. We want to now visualize the length of each. So let's get print maybe length of, we can print the length of, let's say the length of, let's get the length of the training data set of this data set. Run that. Okay, let's get that. So it tells me that it's 75. So we can also get the length of this, or we can print them just in one. So let's just print them in just one line so that we don't have a lot of lines of code. So I can want to print the length of the validation data set. And also I want to get the length of the, what is this? The test data set. So yeah, so we can just print them just in one line of code. I just don't want to have all that. So we have the batches now. We have 0.8, 80%, 10%, 10% of the data set. So that's give you that. That's how we have splitted our data set using this function. Okay. So now that we have split it, we need to go on to pre-processing it, doing the data transformation, argumentation, rescaling, resizing, and so on. So I'm also going to copy another function which is really okay. So we can have that. Yeah, so like I said in the previous class, with TensorFlow, with this input pipeline, it ensures you to have a faster working, fast working in a way that this prefetch is that as one batch is being, if you remember from the previous class that it gets data in batches, and then when the one batch is loaded, another one is also prefetched. So this is what this code will do. And it makes it faster to achieve this. And then the next code is that we're going to now to start pre-processing. You know, these images are from 0 to 255. So we want it to rescale it to between 0 and 1. So this is the next part where we're going to resize our image, as well as we're going to rescale our images. So image size, if an image is not in 255, because we have defined our images size as 256. So if it's not in 256, it's going to be resized to 256, and then it's going to be converted in between 0 and 1 using this scale. So that's how another data argumentation is we're going to do some random flip and some rotation. So this is the part where we start doing data argumentation. So let's run that. You can also run this, run that, and we are. So we have done, so this is the part where we are doing transformations. So we are, like I said, the pipeline is you first get your data from the disk. We have done that, checking data from our disk. We have read all the files. We have read the folders which correspond to our image classes. So the whole data set has 3,000 files belonging to 3 classes. These 3 classes are tomato bacteria, the one with the virus, and the healthy. And then we have printed the length of the data set, and this length, it's 94 because it corresponds to the number of batches that are there, or our batch size is 32. Then after that, we have printed the shape, seeing that is 32 with the images was 256 as the image size, and they are colored images. That's why the number of channels is 3. And then we have shown that in these batches, they are displayed as tensors, and these tensors, you can convert it into NumPy. So using this, converting it into NumPy, and you can see it's a range between 0 to 255. Then we started visualizing. This is just like similar to what we did in the previous classes, but only this, we have used, we just wanted to display the images to see how it is and its corresponding label, and printing this is a repetition, printing more than one image. So you printed this using the matplotlib, and we've defined a function that can split our data set into training, testing, and validation batches. And after that, we've used, we're doing transformations now to our data set, and we've rescaled it, resized in case the image is not 256 length and width. And then we have also done some random flip and some rotation. So this is the part, this is the end of the pre-processing. That we collected our data from, and this is the data that is taken from Kaggle. And also we've done some pre-processing, which was, and yeah. So this is the end for this part. We're going to now, the next part is going to be how we're going to train our models. So yeah, this ends for now.